Welcome to this module in our titration video series. We're going to be covering discovering application policies using the titration ADM feature. So, Remi, we were actually looking at in our earlier module exactly what the policy lifecycle looks like. We were even exploring what a complete workspace looks like with the policies inside that workspace. But now we want to step back actually and go through the actual discovery of those application policies, how we can utilize titration's big data and machine learning to generate a set of policies for me.
Sounds good. I heard lots of promise in other videos on wonderful automation and simplicity, so I'm curious to see that.
And I've been sprinkling that machine learning word so many times that we actually have to get to that point. But in this video, I'm actually going to get you to explain what machine learning is. So
that's easy.
The honor is for you. Right, so we have our workspaces screen up right now, and we are only showing 3 workspaces because we don't have a workspace right now for the core banking application. That's the one that we want to discover the policy for. So we're going to come and create a workspace for the core banking application. To do that, we're going to select the scope of the workspace, which we covered in the scope module. That defines the group of endpoints that we are going to look at to develop the policy for.
So that's the big bucket, right? You were talking like, you say 100 or 1,000 or whatever number we put in there. That's like the large block.
Okay. This is really just the coarse bucket of endpoints that we want to develop a policy for. So we will call this banking core prod. You can choose whatever name you want for the workspace. You could put a description as well. We're going to skip that and we'll click create. So right now, we have our workspace.
Seems pretty empty, Tim.
Seems pretty empty, right? Seems pretty much like a lot of knowledge that people have about what their application policies are, which is about 0.
Yeah,
right?
Well, though the catch-all would be allowed, let's be fair to them.
Yeah, I mean, it's usually permit any. But in our circumstance, we have the catch-all set to deny, which means if we don't actually put any policies in here, every flow, what's going to happen to it?
It's not going to work really well, I think.
It's not going to go down very well, is it?
So I think that's a good point of saying you should not enforce this workspace.
You definitely should not enforce this workspace. So we could go and start putting policies in by hand if we knew those policies, or we could even use the API to bring those policies in. But in the majority of situations, that is not known ahead of time.
Well, wait, so you said I can use the APIs, I can use the manual policies, I can use ADM. Can I mix them?
Yes.
Okay.
You can absolutely mix them. You can start with ADM. You could export those ADM results out. You could analyze them in a different system. You could bring them in through the API. You can take the ADM results and add manual policies to that. There is no restriction on how you design your policy. ADM, in many circumstances, is actually just the initial round of developing what the policy should be.
Okay. So it's not exclusive control. It doesn't require exclusive control.
No, it doesn't take over the workspace at all. So we could either click Start ADM Run in the top right-hand corner here, or we could choose Automatically Discover Policies. Both will take me to the same screen.
I prefer Automatically Discover Policies.
That sounds a little bit more fancy, right? Yeah. So I'm going to go for that one.
So we'll nice big in the middle.
Yeah. We'll click the easy button. So here we go. We can see the automatic policies has taken us to our ADM Run screen. So we're going to say, let's analyze, I don't know, the last 6 hours of data that we have available to us. And then we're also going to look at the workloads that we're going to analyze. So we can see here that the scope core prod has 10 workloads that are eligible for application dependency mapping.
So what does that mean? Does it mean they all need a sensor? Or?
It doesn't mean that they all require a sensor. This is just the workloads that happen to be in this scope. It might be the majority of workloads do have a sensor, but it also could refer to workloads where you don't have the sensor installed. Let's say, for example, you have a physical load balancer that you are getting network traffic from via ER-span, or you have some appliance that you simply can't install the agent on. They'll still be eligible for policy analysis.
Okay. Yeah, that's good.
So you can see here that in our core prod scope, we have a number of different CentOS workloads here. And we don't know anything about these workloads at this point in time, apart from the fact that they are part of this application.
Okay.
You can see that they all have random IP addresses. There's no logical ordering to those IP addresses, and they do have host names, but those host names are just representing a little bit of information, not a huge amount of information about that application. So you can see here that we have 10 member workloads, and none of them have any logical ordering to them. They have sort of randomized host names somewhat. The IP addresses certainly aren't in any logical ordering. So we just have that group, that very coarse group of endpoints that we don't know anything about in terms of what happens inside the application.
Okay. So you're saying that basically IP address doesn't really matter in that context?
Absolutely
host
not.
name doesn't really matter either?
No.
Okay. And, OS and host name doesn't matter either?
No.
Nothing matters there?
All of this is going to be based on the behavior that we see from that telemetry that we've got from those workloads.
Sounds good. So I could have 1, 2, 3, 4, 5 in terms of host names. That would be fine.
Yep. You don't have to have any specific naming convention for your host names.
Perfect.
So let's hide that. And we're going to look into some of these more detailed bits of configuration in one of the later modules in this series, where we'll delve deeper into external dependencies and advanced configurations. But for now, we're just going to click Submit ADM Run. We really don't need to do anything else. We could choose the time range, or I should say we could extend the time range. But in this case, we're going to stick with that initial 6 hours that we selected. It's okay.
What's the impact of just making it longer or shorter?
So for lab, obviously shorter means that the results come out of the system faster. When you're talking about production applications, you probably want to look at a larger period of time to make sure that you capture all of the behavior of that application.
Okay. So there's no, I mean, the minimum window is what, 6 hours, right?
Yes.
Yeah. So
actually, you can even do 1 hour if you want, but I would definitely recommend that for the lab.
Okay, that doesn't sound good. So,
yeah.
So okay, so say, let's go for 6 hours, and then you can extend that to longer periods. What's the sweet spot you see for those?
I would say most production environments, we're talking a couple of weeks to a month to run the initial ADM results on. You can continue running it as well to extend that time period as well. So if you are interested in getting 2, 3, 4 months worth of data into your results, you simply just re-execute the ADM algorithms over that increasing time period.
Okay, so I could start like now with 6 hours, then I could extend that to 2 days, then I can do it on the same workspace, so banking core prod, then extend until 3 months, for example?
Yep, you got it.
Cool, that's pretty nice. Show me the magic.
So let's show you the magic, as they say.
Show me the magic.
I'm going to click Submit ADM Run. That's going to pass that information to the back end of the titration cluster to go analyze those workloads for the grouping of the endpoints and also exactly what dependencies they may have.
Okay.
This might be a good time, while we're waiting for the results to come in, if you could actually explain to me what machine learning is.
It's magic, Tim.
It sounds like magic to me.
You don't ask any questions, it's magic. There's a few things around it, obviously, and machine learning is a massive topic, so there's no shape or form trying to go into details. It's just to get a conceptual view of what's happening here.
Oh, I thought you could explain it to me in like 2 minutes.
Sure, Tim. Sure, Tim. 2 years, maybe.
All right.
So let's take a few examples there. For the sake of these examples, we're just going to put workloads as dots. So it's just going to be one workload, a second workload, a third workload, fourth, etc., across the environment. I'm sure you enjoy my perfect circles.
Fantastic.
Fantastic, right? So imagine that's your environment. So how do we calculate those dots? Well, those dots are actually what you have already mentioned, which is actually data. So the flow data that comes in, the process data, actually makes up a dot. And this dot is plotted. So you get this kind of view there that is absolutely not a network map in any shape or form in terms of approach. It's just like a bunch of dots on a sheet of paper.
So you're saying those dots weren't just randomly placed there by you. They were actually placed based on the behavior of the workload. Absolutely.
They're placed on the behavior of the workload, allows us to place dots in some places here.
Okay.
And then what the algorithm is doing is a whole bunch of iterations. You remember your engineering classes? You heard this thing called k-mean?
Yeah, it was a while ago. Not as long as you, but it was a while ago.
Sure, it was like last week, okay. So the logic of k-mean is sort of the same logic as that in there, just to get a sense on those kind of algorithms. So it calculates the distance between different dots and tries to find a way to group them with the most, let's say, linear distance between each of them. So if that was 1 and that was 1.1, and so on, they would probably be grouped together. But for example, between those two here, I mean, they're pretty far off.
So you're saying the further the distance is, the less similar they are.
Exactly.
Okay.
And so by doing that, I'm going to be able to build out some groups. So for example, let's say this is one group of servers, first pass. And then let's say this is another group of server, and that's a third group of server on the platform.
Okay.
That's the first iteration. Now, if we look at that, say, okay, it doesn't sound perfect, right?
I mean, maybe you could take a second pass.
Let's take a second pass. And let's say that for this one, in the second pass, it recalculates the distances, and the distances are actually better like that, and maybe like that, and maybe those three together, and this guy on his own.
Okay.
And that's what's happening in the backend at the moment. It's actually running different variations with different placements to see, okay, where actually do the circuits match the best possible.
And how many passes are we talking about here?
Could be thousands, could be millions.
Okay, so it's not something that you would want to do by hand at all?
I mean, you can try.
Okay.
I mean, I can give you my phone as a calculator on it. You can go and run them manually. That's an option if you want to go that route.
No, I'm happier to let the machine take control here.
I think that's why those kind of big data problems, tick the box for big data now, we've said
Okay,
it.
yep.
The value of those big data problems is actually that you can actually run so many iterations at high speed with huge amount of data. Can you do that manually? Yeah, absolutely. Look, find a way to plot the points. Every single flow is potentially a point you're plotting. Don't forget that. Mm-hmm. There could be a whole lot of them. Plot the process data. Plot any other data we're actually capturing to help us. Like stupid things. Who's the client? Who's the server?
Seems important.
Seems basic, but for some reason, I mean, that's not an easy problem to solve.
No,
actually.
Absolutely not. Okay, so the more data we're passing into the system, the longer period of time, the fact that the titration sensors are capturing such accurate data means that the plotting of those endpoints is going to represent the agents and those workloads more accurately, and therefore the grouping is going to be more accurate and more likely to be right in the first iteration of ADM.
Exactly.
Okay. Well, that sounded cool. That was interesting, but actually I'm kind of happy the fact that the results just say results available, and I didn't have to know that myself to use this system.
I think that's important. Plus, I mean, you see, there's no place where we actually put it. I mean, it doesn't matter, and that's just like super high level. But there's much more algorithms being put into that than just finding like distances between dots and stuff like that.
Okay. So, despite the fact I would like to have machine learning and big data on my resume, I don't need to have it to use titration and get the benefits of those tools.
Exactly. Look, did you type any kind of fancy number or anything in the UI?
No, and unfortunately that means I can't ask for a raise to say that I'm using big data now or machine learning.
You can try.
So let's click our results available in the top right-hand corner here and see what the system has created for us. Okay. So we are at the Banking Core Prod application. And the Banking Core Prod application has derived for us the fact that there is 6 clusters, 10 workloads inside those clusters, and we can see that it's apportioned them into those different clusters based on their behavior. So I see that there is a banking app cluster, which I can expand. That looks like it has the active and standby endpoints there. That makes sense. Even though the fact that they are potentially in different states right now, they've been grouped based on the fact that they are still application tiers.
I appreciate that you put them on different subnets as well. Very important.
Just to prove that you don't have to readdress your workloads to get this microsegmentation working.
Perfect.
We'll be looking at the database load balancer here. It's created that group name again based on some of the similarities of those workloads. I can see that they are grouped together. We also have the statement generator group, the banking web group. That just looks like it has one workload in the statement generator, but the banking web, yes, that does have 3 workloads in there. While they share a similar host name, they have totally different IPs again. And then finally, we have replica 1 and replica 2 of the databases. So we've clustered these workloads together into different groups based on what they've been doing. So I now know that I have these 6 clusters available to me, and I can also see in the top there that I have some policies as well 40 policies it looks like it has created.
Okay.
So we can take a wander over to the policy section as well.
Well, yeah, because right now, okay, great. I mean, you can put whatever you want in those guys for me. Right?
Yeah.
So what does that actually give out? So you have 6 clusters were added, and those 6 clusters have generated 40 policies.
Correct.
Is that what you're saying?
Yes. And so let's take a look at that. Well, I can see a couple of things. So I can see that this application is talking to the services. I can see that it's talking to a message queue, to the key value store, and I can also see the relationships inside this application as well. I can see that the campus has been talking to this application via the web tier over port 443. I've effectively discovered every single dependency for this application, both intra-application dependencies and inter-application dependencies. So what we could do at this point is we could either plot this on the graph to take a look at it visually, or we could go edit these clusters a little bit to just rename them and come up with something that's slightly easier for us to read. So let's go and do that.
Just before you go, you move to the next screen, I was just looking at that, and I mean, that looks to me like true microsegmentation. You're not building micro zones here, right? It's proper micro segments. You're looking at individual IP, you're regrouping them into mini areas and so on, but each host is still individual inside those groups, right?
Correct. This really is true micro-segmentation, right down to potentially even the individual workload being in its own group.
That's pretty nice.
It is. And it's nice that the fact that even for a simple application like this, there's 40 policies that might need to be put in place. If we talk about a larger application, a real production application, it might be on the order of thousands of policies that you have to capture to correctly whitelist that application, something that you could just simply never do in a manual fashion.
No, definitely. And how long did that take? A few minutes?
A few minutes. Just enough time for you to explain machine learning to me.
Yeah.
There we go. So we're going to click the clusters tab over here, and that's just going to show me some information about these workloads. So you can see that the workloads that have, or the clusters that have 2 or more workloads in them, we have a confidence score. The confidence score, well, can you explain a little bit about that to me?
Yeah, sure. I mean, if you go back to the diagram, we're talking about the confidence score. As part of all this, not to go into too much detail, there's a thing called a centroid, which is actually built, which is supposed to be the center, the mean of the distance between all of them here. Yeah, it's not exactly a straight line, but we'll go for that.
That's okay.
So that's the centroid, and each of one of them is going to show a number. So if this average number is actually very small, then the confidence is very high, because it means they're very close to each other.
So the more similar in behavior they are, the closer they're grouped together.
Yeah, the more accurate the thing is. So could we put a number in there? Yeah, I mean, you could come up with a number. The question is that if I put you a confidence of 0.77, what does that mean? Is it good? Bad?
Who knows?
Is 0.9 better? Is it 0.1 bad? I mean, you see,
yep.
That's the thing. So it's sort of translated in a way that you can understand, but that's actually what's happening behind the scene. Is the mean, this distance here and the deviation between this distance.
Okay. So in short, if the confidence is very high, we're much more certain that these endpoints should be grouped together.
Exactly.
If the confidence is low, that means that there's less signals coming into the system to actually make that distinction.
Exactly. Which probably means you don't have enough data.
Okay.
That's most of the case, it's that.
All right, so if we're taking, let's say, ER span data, and we have a low confidence, we could achieve a higher confidence by putting agents on those workloads to make sure that we have more data to analyze.
Yeah, process data would make it more accurate, because that's going to come up and build out this number to some better number.
Okay, that makes sense. So let's go ahead and just edit some of these, and we can rename them. But also, I'm curious to see about how we might be able to look at this cluster and reevaluate it based on the tags of those workloads. So I can see here that this is called banking app. And if I click edit cluster query, we can see that it has initially generated the query for me based on the IPs of those workloads. Sort of random looking IPs, not exactly sure what that IP represents, and there's a good chance that that's going to change. If I migrate that application, if I respin that workload, the IP is very likely to change.
There's a chance. By the way, I just noticed that you just changed the name.
I did change the name as well while we were talking. I just removed some of the extra characters in there. We're just going to go do that into the rest of the clusters so that it's easier to look at. It doesn't change any of the semantics of the policy. The policy still works in exactly the same way. Just makes it easier for me as a human to read what's going on.
Okay, so that's purely cosmetic.
Purely cosmetic.
Okay.
And you know I love the cosmetic.
You don't like the
things.
dash star, I
Yes.
see, okay.
So we have the two alternate queries here. What it's doing for us now is suggesting us alternative ways that we could achieve the same end result. I want those two endpoints in this group, but there are other ways to specify those endpoints. It could be the host name. Here, for example, they share the same host name, being banking app.
Okay.
That's one way to do it, although it might not necessarily be the best way to do it. Host names change. Host names aren't always predictable.
Because your host names will very definitely change, I think.
Yes, they look like very randomized host names. So let's go with something else, which here is a annotation. So we have annotated these workloads with the fact that they are part of the tier equaling app. So Tetration has said, hey, we could do this in a different way, which is anything that's tagged with tier contains app. That's going to come up with the same result. That means if I migrate that workload, if I scale this application tier out, if I have a disaster recovery scenario, as long as those workloads are correctly annotated, and those annotations, as we've covered before, will be able to come in through dynamic systems, it's going to automatically update the IPs in this policy.
Sure, okay, and just for the people who didn't look at the rest, that would be bad, but anyway, let's imagine that annotation is like a tag, right? Same thing.
Yeah, it's just like a tag, a label, any type of metadata that you might want to associate with these workloads, and we can dynamically ingest them from orchestrators like AWS, vCenter, or Kubernetes.
So which means that if I decide to rely on tag, let's say I have a tagging structure I define, and someone adds a tag in AWS, and then I can pick up the tag, get it there. But on the flip side, if someone also downscales a system and moves, for example, you had one system with 3 nodes, if I were to remove one, this IP would disappear as well from the policy.
Exactly. So no longer do you have the ghosts of the firewalls past and the rules stuck there, eating up space that shouldn't be in that particular rule set. So we can save that one, and we can go ahead and do the same for the rest of these tiers. So we'll just click Edit Cluster Query. We'll come rename this one to say just LB, remove that. You can see that it's chosen us the tag tier equals database LB.
Okay.
Again, you don't have to have these tags to get started. They don't have to be in the system. It's going to do it just based on the flow data and the process data. But the more tags, the more annotations that you provide, the more dynamic your policy can become.
So you're saying that I could potentially take it out of the box as it ran there, hit the enforce button, and enforcement will work. Okay.
So we'll just edit the last few ones of these. So we have our web tier.
See, you're particular about your naming.
Yes. One more or two more. We'll get the replica 1 sorted out.
While you're doing that, just my understanding, when you use contains, it's just because you want to make it case insensitive and just match a part of the name, right?
Correct. Contains is going to match a subset of the annotation. Equals has to match the entire annotation.
Including case.
Including case,
Yeah.
correct. So we're going to choose, we could choose contained in this case. It's just going to come up with the same result, this one being contains, this one being equal. However, if I had another workload that was tagged with DB replica 2 and something else in that particular string, it would also match it as well. So
Okay.
you have the choice as to exactly how specific you want that match to be.
Okay. Now, one thing, because you forgot to click on one, so now I'm going to ask the question, obviously. Why is there a confidence very high here versus approved here?
That's a very good question. And the reason being is we didn't click approved on this one, or I should say we haven't yet chosen the query for this one. So this one is still based on the results of ADM. This one still has a very high confidence because if I reran ADM, it is actually going to potentially change the result of that. It could increase the number of workloads, it could decrease the number of workloads. Until I click approve and say that this cluster is how I want it to be going forwards, it is going to continue to hold that confidence interval there.
I see.
You can approve it also just by selecting a query. By selecting a query, you are essentially approving it.
I see. So if I say approved, it means someone went in and just blessed it in some shape or form and just said that's what it is, it's okay. And there, the confidence interval doesn't really matter anymore.
Confidence interval doesn't matter anymore. At this point, It is driven by the fact that you as a human have approved that particular cluster.
Okay, sounds good.
So now we have our clusters renamed. We have our policies, which we can view again.
Did that change the policies, by the way, what you just did?
It didn't change the outcome of the policies. It didn't change how they would be enforced. Everything is exactly the same. All it did is, again, change the cosmetic side. It just changes what we see in the user interface.
Okay, I see. And so based on what you just said, what you're saying is that here it's an intent really that you're showing, because you put tags everywhere, so it means the membership is variable, I guess.
Correct.
But the intent is always the banking app can talk to inside whoever is banking app.
Yes.
And that the rendering is a different story, completely right.
Correct.
Okay.
This is just how I believe or how I want this application to act from a policy perspective.
Okay.
So then finally, the last thing that we could do in this section is go ahead and create the application view. This is going to let us visually represent these policies in a way that might be more familiar to an application developer.
You mentioned diagrams. I want to see diagrams.
Let's go take a look at that diagram. So we'll click application view here. We'll call it app view.
So it says view, so I'm guessing it's like read-only. It's like just literally a view of what is there. It's the same data, but just presented differently?
Correct. It's the same data, and when you click here, you'll see it's a blank sheet of paper with some objects on the right-hand side that I can choose to drop onto the canvas or not show on the canvas. You can have multiple application views. It doesn't really affect the policy that is going to be enforced on any workload. It might be that you want to have a high-level application view to show to executives and a more low-level application view that shows all of the very, very detailed policies to someone that really cares about those, perhaps a security user.
So you're saying on the right side here of the screen, this kind of tree format, that's what allows you to show like big picture for like people that don't care about the details, let's put it like that.
Yep.
And then you can go down inside each of them. You can go to the leaf level inside this tree, and that would bring the like very fine
detailed. Yep.
Yeah.
So let's go and do the detailed one today.
Yeah, I was going to show me a geek picture.
Yeah. So let's drop down the web tier. Actually, I'm going to drop down the campus first. Then we can drop down web. We can also drop down the applications here, the load balancer, and let's start double-clicking some of these to resolve the dependencies. So I'm going to click on Acme Campus.
I was going to say up to now it's nice, but just like single dots.
Now we can see by double-clicking that, it's showing me that the campus is speaking to the web tier over port 443.
Did it just rearrange for you, by the way?
It did. It will dynamically continue to rearrange as I click these. So if I click banking web, it's going to show me the dependencies of the banking web. So it speaks to the inside of the data center, it speaks to the cloud services and the banking app.
Okay.
If I double click banking app, it's going to show me the next layer of dependencies. So I can see that the banking app itself is speaking to the database load balancer, the statement generator, and the key value store. And finally, if I click the load balancer, it's going to show me the final part of this tree, which is the load balancer speaking to the replica 1 and replica 2. So now I have a diagram that's going to show me exactly how traffic is flowing through this application, and I can rearrange it if I choose to do so.
So this view at this point, so would you recommend, first of all, would you recommend that you actually build it up just the way you did? Or should you just put everything down and double click everywhere and just like eyes closed and see what happens?
I think it's nice to build it up because you can understand the individual dependencies of that one tier. So as you double click it, it resolves that tier, and then you can choose how you might want to resolve the next one afterwards.
Okay, so that means, can I have multiple of those or can I only have one?
Of each one of these different views, you can have a map from every single perspective. You could have tens of maps if you want. You could have a map from the perspective of the application tier, or a map from the perspective of the database tier. There is no restriction, and like you mentioned earlier, it's totally read-only, so it won't affect any of the policies.
Good, so I mean, I can give, with RBAC, I could give access to someone to this environment. He could go create his view based on something I've designed, like for example, the policy views, and build up exactly the way you did for his understanding without breaking my stuff.
Yes.
Oh, that's really cool.
So at this point, we have our application policies discovered. We have our clusters discovered, which were automatically grouped for us. And we've built an application view that shows us some of the structure of this application.
Okay.
Next up, we probably would want to move on to policy analysis and then finally policy enforcement, but we will save those for future modules in this training series. So unless you have any more questions on application dependency mapping, which I think we have covered, at least at a basic level, and we will go into more details about how you can do application dependency mapping, we're pretty much wrapped up for this session.
Sounds good. Yeah, I'd like you to talk to me about shared service and stuff like that in the next session.
We will definitely get to that.
I appreciate that.
So with that, I would say thank you to you for joining us as well. If you would like any more information about application dependency mapping and titration, please visit cisco.com/go/titration.